Hello everyone. In this video I am going to discuss a question which is find the domain of the function f(x) is equals to root over minus of log base x plus 4 by 2 of log base 2 of 2x minus 1 upon 3 plus x. So let's solve it. So as we know that this function will be defined when the quantity inside the root, which is minus of log base x plus 4 by 2 of log base 2 of 2x minus 1 upon 3 plus x, will be greater than or equals to 0. So on doing minus multiplication, this quantity can be written as log base x plus 4 by 2 of log base 2 of 2x minus 1 upon 3 plus x less than or equals to 0. As we know that on minus multiplication, inequality sign will be reversed, right? So now here as we can see that this logarithm base x plus 4 by 2 is a variable quantity. So we know that logarithm will be defined when the base of the logarithm will be in between 0 to 1 and it should be greater than 1. So let's see here, two cases are there. Let's take here case number 1. When the base of this logarithm, which is x plus 4 by 2, is greater than 0, less than 1. In this situation, when we are solving this inequality, we are getting here x should belongs to minus 4 to minus 2. Let's suppose this is our equation number 1. So according to this, when this logarithm base is in between 0 to 1, then this logarithmic value should be less than or equals to 0. So as we know that logarithm graph, from logarithm graph very easily you can see that logarithm graph will be like this, log base ax, when a is in between 0 to 1. So in between 0 to 1 means logarithm base is in between 0 to 1, then logarithm is decreasing. The graph of the logarithm is decreasing, right? This is origin here. So you can see logarithm graph when the base is in between 0 to 1 is above x-axis in between 0 to 1, means when x value is in between 0 to 1 it is positive, and when x value is exactly 1 then logarithm value is 0, and when x is greater than 1 then logarithmic graph is going below x-axis, means it is negative. So we want this logarithmic value should be less than or equals to 0, means for this logarithm this is argument here, so this entire argument should be greater than or equals to 1, then only this logarithmic value can be negative or equals to 0. So we are writing the log base 2 of 2x minus 1 upon 3 plus x should be greater than or equals to 1. So here as you can see, the logarithm base I am transferring here, it can be written as 2x minus 1 upon 3 plus x greater than or equals to 2 to the power 1, which is 2 only. Taking 2 on this side, on simplification we can write down 2x minus 1 minus 6 minus 2x upon x plus 3 greater than or equals to 0. Further on solving, we can write down here 2x is getting cancelled here, minus 7 upon x plus 3 greater than or equals to 0. So minus 7 upon x plus 3. So again I am going to do minus multiplication, so it will be written as 7 upon x plus 3. But here I had done minus multiplication, so what will happen? Inequality sign will be reversed here. So greater than or equals to 0 will become less than or equals to 0. So here we can see this value should be less than or equals to 0. When here numerator is 7, which is a positive quantity, so entire value cannot be equals to 0. So it will be less than 0 when the denominator should be negative, because numerator is positive, so denominator have to be negative, then only it will be coming less than 0, right? So x plus 3 must be, that will provide us x plus 3 must be less than 0. So from here we are getting x should belongs to minus infinity to minus 3, right? Let's suppose this is our equation number 2. So in the case 1, when the base is in between 0 to 1, then this logarithm will be less than or equals to 0 value will be giving you when x will belongs to minus 4 to minus 2 for base condition, and for argument condition x should belongs to minus infinity to minus 3. So what we will take? Intersection of 1 and 2. So 1 intersection 2 we can write down here x should belongs to, on taking intersection we can easily write down minus 4 to minus 3, right? So this is here the case 1 solution. Means when the base of this logarithm is coming in between 0 to 1, then this function will be defined. Correct? Another case is there when the logarithm base, which is x plus 4 by 2, will be greater than 1. Right? So let's see here. I am writing just on the next slide. Log base x plus 4 by 2 of the quantity was written log base 2 of 2x minus 1, log base 2 of 2x minus 1 upon 3 plus x. 3 plus x. We want this quantity less than or equals to 0. So less than or equals to 0. So case 1, as you know that we are taking the base in between 0 to 1. Now case 2 I am taking here, which is x plus 4 by 2, the logarithm base greater than 1. In this case, when we will solve this inequality, we will get here x should belongs to minus 2 to infinity. Let's suppose this is our equation number 3. Right? So here, in this case, when logarithm base is greater than 1, so we know that the graph is increasing. The graph is increasing means this is the graph of log base ax. Here this point where it is intersecting the x-axis is 1, 0. So you know when x is greater than 1, graph is above x-axis means positive value, and when x is in between 0 to 1, then graph is below x-axis means negative value, right? So from here we can say the entire value should be less than or equals to 0. Base we had given condition that base is greater than 1 for x belongs to this value. So base is greater than 1, we want entire logarithm value less than or equals to 0, means this argument, which is log base 2 of 2x minus 1 upon 3 plus x, this must be greater than 0 and less than or equals to 1, right? On solving this, transferring the base, we can write down 2 to the power 0, which is nothing but 1 only, and here 2x minus 1 upon 3 plus x less than or equals to 2 will be transferred here, so 2 to the power 1, which is 2. So on solving this left sided part of the inequality, we can write down easily 2x minus 1 minus 3 minus x upon x plus 3 greater than 0. So on simplification, we can write down x minus 4 upon x plus 3 greater than 0. On applying Wavical concept, we can say x should belongs to minus infinity to minus 3 union 4 to infinity, right? So we had solved the left sided inequality. Similarly, solving the right sided inequality, let's remove this graph here. When we are removing this graph, so we can write down here, 2x minus 1 upon 3 plus x less than or equals to 2. On solving this inequality, we can write 2x minus 1 minus 6 minus 2x upon x plus 3 less than or equals to 0. As you can see, 2x is getting cancelled, so it will be coming minus 7 upon x plus 3. So on multiplying minus sign, we can write down 7 upon x plus 3, and since I am multiplying a minus, so inequality sign will be reversed. It will be coming greater than or equals to 0, right? So as you know that numerator is already positive, so denominator must be positive, then only quantity will be coming greater than 0. So x should belongs to, or x plus 3 should be greater than 0. That will provide us x should belongs to minus 3 to infinity, right? So in this case, when this quantity is in between 1 to 2, for what value of x? This quantity should be greater than 1 and less than or equals to 2. So we have to take intersection of this and this. Let's suppose this is here equation number 4 and this is our equation number 5, we can say here. So taking intersection of 4 and 5, we can write down here x should belongs to 4 to infinity, right? It is saying greater than minus 3, it is saying less than minus 3, no intersection. It is saying greater than 4 and it is saying greater than minus 3, so intersection is 4 to infinity, right? This is here the value of x, so that this quantity will be in between 1 to 2 and 2 will be in closed interval, right? Let's suppose this is our equation number 6. Now according to the case 2, the base should be greater than 1 and this argument should be in between 0 to 1. So argument is in between 0 to 1 for this x value. So base is greater than 1 for this x value minus 2 to infinity. So we have to take the intersection of 3 and 6. So intersection of 3 and 6 we are getting here. X should belongs to 4 to infinity only. It is saying greater than minus 2. It is saying greater than 4. So 4 to infinity only. So this is here case 2. For x values between 4 to infinity, this logarithm will be less than or equals to 0. This is case 2 conclusion. So this function will be defined in two cases. Case 1 when x will belongs to minus 4 to minus 3, or case 2 when x will belongs to 4 to infinity. So we can say here the overall domain of the given function is, here I am writing case 1 union case 2. So it will be coming here minus 4 to minus 3 union, here we are getting 4 to infinity. 4 to infinity.